Welcome, guys. So yesterday we were, talking about ratios, percentages, right? We talked about decrease percentage, increase percentage. We also saw regarding cost price, selling price, profit and loss, right? So in this video, again, I wanted to recap on ratios as well as percentages because these are very, very important, aspect which will be used in your later years, right? See, personally, I also have been doing a lot of research about how joint entrance examinations are conducted these days, right? My own children, they are in their ninth standard right now, and we are laying down a map for joint entrance examination. So what I find is JEE main constitutes topics from NCRT syllabus, and it can be any question that can be drawn from your 8th standard onwards to 12th standard, right? So qualification of JEE main is one of the important aspect towards your IIT admission, right? Only if you qualify with a certain percentile in JEE main would you be allowed to appear for JEE advanced, right? So JEE main is predominantly based on NCRT syllabus. Hence, it is very, very important that from the 8th standard onwards, we stay focused on mathematics lessons in particular, because this is going to play a very, very important role in your career. All right. So coming back to our subject regarding ratios and percentage, see, let me recap. Let us say you have one banana which is cut into four parts, okay, and there are two children to whom you have to give these bananas. So if you distribute to them equally, right, two pieces to each one of them, then you are actually dividing in the ratio 1:1, right, because both of them are getting equal proportion, right? Contrary, let us assume that to one child you are giving 3 portions and to another child you are giving 1 portion. Then it means that one child is getting a larger portion, right? So the fruit, the 4 parts have been divided among these two children in the ratio 4:1. 3:1. Okay, 3 parts to one child and 1 part to another child. 3:1. In this fashion, you are distributing the bananas. So this is where ratios play a significant role. So if there are ratios of 3 different collections that is given, let us say the ratio between the number of males to number of females to number of children in a particular street is 3:2 let us say 5, right? 3:2:5. This is the ratio of number of males to number of females to number of children. So what it means is 3 plus 2 plus 5 is 10. So if there would have been 10 people in that street, out of those 10 people, 3 would be males, 2 would be females, and the remaining 5 would be children, right? So this is what it means. Now we will have to find out, assuming that X is the total number of population and assuming that number of males and number of females are given, we will be able to find out number of children, okay? Or even if one data is given, you will be able to find out the other data. So this is what ratio signifies. So you have a whole part, and how the whole part is distributed to different collection is what ratio signifies, okay? You have a whole part, in this case population in a street, right, and it is divided among males, females and children in the ratio 3:2:5, okay? So the whole part is 10, 3 is male, 2 is female and 5 is children, right? So if there would have been 100 people in that street, right, what we can infer, 30 would be males, 20 would be females, and the remaining 50 would be children, right? So you can easily find out how many males, how many females, how many children would be there if the total is given. All right, so this is ratio. But when it comes to percentage, we know that for a certain number or in a certain number, right, a subset of that number. Okay, for instance, let us assume a basket of balls. All right, so you have red colored balls, yellow colored balls, and green colored balls in that basket. All right, so assume that there are 300 balls in that basket, and the number of red color ball is 100. Okay, so out of 300 balls, you have 100 red colored balls. So what is the percentage? Okay, so when we say percentage, for 300 you have 100 red balls. Then what is it in terms of 100%? Per 100, how many red balls will be there? This is what we mean by percentage. Percent, okay, which means cent is 100. Per 100, what it would be? For 300, you have 100 red balls. All right. So percent per 100, what it would be? All right. So here what we can easily find out, when the total is 300, we have 100 red balls. All right. So if it would have been 1, it is 100 by 300, and if 100 balls would have been there, it is 100 by 300 into 100. All right. If you work it out, you will get a certain number. That is the number. When that is a percentage. That number is the percentage. So 100 into 100 by 300. You can cancel the two zeros between 100 and 300. You will get 100 by 3, which is nothing but 33.33. So the percentage of red balls, to the total number of balls available is 33.33%. So here you have to clearly differentiate between ratios and percentages. Ratios are the way the whole sum is divided among certain collections, wherein the percentages, okay, out of the whole, a particular collection is available in so many number, which means percent per 100, what would be the number of that particular collection is. Okay, so that is why I have given certain examples. There are multiple ways of finding out percentage. We are saying per 100, right? Let us consider a fraction called 22 by 55. All right. So how do you find out the percentage? It should be per 100, right? Percent is nothing but per 100. So you have to have 100 in the denominator. All right. So how will you get 100 in the denominator? In the denominator, you have to multiply 100 by 55, right? Then only the 55 will get cancelled and you will have 100. But whatever operation we do on the denominator, we will have to do it also on the numerator, because the fraction has to be an equivalent fraction. Whatever operation you do on the numerator, you will have to do it on the denominator. Whatever operation you do on the denominator, you have to do it on the numerator as well. So you multiply both the sides, both numerator and denominator, by 100 by 55. Okay. So what will you get on the numerator? You will get 22 into 100 by 55 divided by 100. Okay. So percent per 100, right? You have made a denominator as 100. Percent, what is that number you are getting? 22 into 100 by 55. So if you work it out, that will be around 40, right? So 40% is the answer. Okay. So similarly, let us assume that you have another scenario, right? Another fraction, 25 by 4, or let's say 5 by 4. Okay, what is the percentage of 5 on 4? All right. So what do? You multiply again 25 on both sides. 5 into 25 divided by 4 into 25. What do you get? 5 into 25 is 125. So 5 is basically 125% of 4. Right? It is greater than 4, right? So it is 125% of 4. Alright. So if it is the reverse, let us assume that 4 by 5 is the fraction. Then what is the percentage? What is the percentage of 4 on 5? You multiply both sides by 20 now, right? Because the denominator is 5. So if you multiply 5 with 20, you get 100. So if you do both on numerator and denominator with 20, you get 80 by 100. So basically this fraction called 4 by 5, or the percentage of 4 on 5, is nothing but 80%. Alright. So this is another way of finding out percentages. So if a question is asked, what is the percentage of girls to the total number of students in a school? If you are given the number of girls, total number of students, you first consider the fraction number of girls divided by number of students, and you will have to do an appropriate action so that the denominator becomes 100. Okay, let us assume that the total number of students is let's say 40. Okay, total number of students is 40, and the number of girls available is 10. Then what is the percentage of number of girls to total number of students? So the fraction total number of girls to students is 10 by 40. How do I make my denominator to 100? What is that I have to multiply with? I have to multiply with the 2.5, right? So multiply 2.5 on both sides. So the numerator will become 10 into 2.5 divided by 100. Okay, so 2.5 into 10 is 25, right? So percent, the number of girls become 25 because that is the numerator you are getting. Hence, the percentage of number of girls to total number of students, nothing but 25%. Okay, so you please remember these concepts. See, the concept of rational numbers have evolved from ratio only, because rational numbers are represented in the form p divided by q, where q not equal to 0, p and q are integers, right? This is nothing but this is derived from the ratio, right? Hence, the concepts that we are studying here, it is also used in 9th standard, very extensively. This is the, foundation. This is the basic building blocks for your future learnings. Hence, kindly, go through these lessons again and again. The reason why I'm repeating the video, I'm giving you more example, is because I want your understanding to be complete, right? If you have any doubts, you know how to ask. I have, communicated to you many times. All you have to do is write an email to askmentorguru@gmail.com. Ask Mentor Guru, ASK, Mentor, MENTOR, GURU, mentorguru@gmail.com. Please drop in an email. We will get back to you with our answers and clarifications. All right. So in the next video, we will talk about the many different types of taxes, and we will give an introduction to simple interest and compound interest. All right. Thank you.